Good morning, ladies and gentlemen. I welcome all of you to this session on decentralized identity for travel sector. A quick introduction regarding myself. I'm Debajani Mohanty, SSI expert at EarthID. I'm quoted as one of the top 30 blockchain influencers of India 2021 and blockchain catalyst of India in year 2019 and 20. I'm a solution architect working in blockchain for past 5 years, and I'm also author to 5 Amazon bestseller books on blockchain, some of which are translated to German and Chinese to reach the wider mass. For the past 2 years, I'm working in blockchain backed decentralized identity, and my latest work is on decentralized identity or self sovereign digital identity. With government imposed travel bans and nationwide lockdowns, 2020 will go down as the worst year in the history of modern day travel and aviation industry. In this slide, you can find how negatively COVID 19 has impacted the stock prices of cruise and airline sector and how much the US travel industry has lost in this time period. Nonetheless, 2020 has accelerated digitization and automation of many aviation workflows. Today, increasing passenger safety, boosting passenger confidence, and making airport and airline operations significantly more efficient, adaptable, and intelligent is the new blueprint for survival and growth. In today's session, I would cover the inefficiencies in travel sector, especially in COVID times, certain innovative use cases with self-sovereign identity or SSI and biometrics, and RFID's state-of-art architecture that can cater to the need of travel and especially the aviation sector. For this session, I have selected airlines and airports. Why? Because we professionals mostly use flights for traveling to places and moreover in order to save our precious time. For example, I live and work in Delhi NCR, and at the back of my mind, I always have the thought that my hometown Bhubaneswar is only 2 hours flight from Delhi. But how far that is true? If I add all the time needed by me to travel door to door to my parents in Bhubaneswar, it's close to 6 to 7 hours. And most of this time I spend either in queues or in waiting. So airports across the world are getting busier every year. Traveling as an experience is always chaotic, inefficient, unenjoyable, and unsafe. Can someday in future we can have we can overcome all these challenges and make these processes streamlined, safe, and delightful? Let's find out. From the moment of passenger journeys to a departure terminal, they are faced with a series of small but potentially stressful challenges. First, finding the parking, then finding the baggage card, finding the correct departure terminal, finding the check-in desk. All the while, the passenger might be wondering if they will make it to the departure gate on time. So here is a typical wait time that an airline passenger experiences during the air travel. Perhaps 10 minutes at the check-in, 20 minutes at the security check-in, again 10 minutes in the immigration if it's international travel, and then 30 minutes in the waiting lounge, and then few hours of flight, again 30 minutes in the immigration, 20 minutes at the baggage collection, and finally exit. Each step in this journey could be frustrating. However, the number I have shown here could be far too less. In bigger airports, this number can be painfully much more. In US's Newark Liberty Airport, the security check-in can take up to 60 minutes. In the right hand side, you can find the number of passengers leaving the airports in US in every 15 minutes. The maximum number you can find in US's O'Hare International Airport, which is 485 passengers in just 15 minutes. In this slide, you can find that there are certain areas in the airport where we find either full or partial automation. For example, booking, bag tag, and check-in. However, there are areas where manual intervention is high and the processes are relatively slow. For example, the security check-in and passport or border control. Obviously, you can find that the customer satisfaction is far too low in areas that are yet to be automated. Have you ever wondered why air travel is so time consuming, and even if it's so, can these processes be streamlined? In this slide, you can find all the touch points of the journey where the user's identity is checked again and again. For example, booking the ticket, checking in, bag drop, security, border control, and finally boarding. Now, let's see how the data related to the digital identity are stored and maintained in the existing systems. The first model that came some 3 decades back was the centralized server, where we used either a LDAP or Active Directory or RDBMS to store a separate set of user ID and password for each application. The second model is the federated identity model, where we used a separate identity provider that has a centralized storage again for storing the credentials, and it handles the access to several third-party services. So in both these models, there is a possibility of mass hacking as well as single point of failure. Self-sovereign identity, or SSI, is a new decentralized model to manage digital identity. Here we have an issuer that issues verified credential to the user that is saved securely in the user's mobile device. At the same time, the issuer sends a signed reference hash to the public blockchain, signing it with their own private key. The user then can share the whole or part of the data to a verifier organization along with issuer's public decentralized identity. Now the verifier can convert the data to a hash and check if the hash of the data matches with that on the blockchain to know that whether it's valid. This example can be a scenario where the issuer is the passport office and the verifier is the visa office, and the user is sharing as much data needed by the visa office with the user's own full consent. At a later point of time, if there is a need, then the issuer can revoke the hash by altering a small piece of the data, and the verifier knows that the data is no longer valid. This architecture ensures integrity, ownership, privacy, security, and the validity of the data. And please note that in this architecture, there is no centralized data store. SSI in real life is far too complex. Let's say that Alice is born in a hospital. So the first set of verified credentials you would receive from the hospital. Now she applies for her national identity, and so the government is approving and allocating the national identity. Then she is producing both these credentials to a school or a college where she goes for her education, and on completion the university is again issuing one more set of verified credential to the user, and finally she is joining an organization as an employee where she has to produce the certificates from all the previous issuers. So So all this kind of verified credential can be allocated, and she can safely secure this in her own mobile device. And as per the need, she can share this information with different verified organizations, and she can also share this information, this personal data, in three different modes, which are the traditional mode, zero knowledge proof, and this selective disclosure mode, and self-attested mode. In traditional mode, I'm sharing my name as it is, that is, I'm Debajani Mohanty. In zero knowledge proof mode, I'm just answering in true or false. Like somebody is asking me that whether I'm an adult, I'm just replying saying that it's true, and it can be verified. And the third is the self-attested one, where you do not need to get a verified credential for anyone. You are sharing this data on your own, something like your hobby or something. So again, these datas are actually the hashed version of this data is available on a public blockchain. So this hash is created and stored by the issuers, and the verifier can check the validity and the integrity of the data on the public blockchain. Again, I'm telling you that actual data doesn't go to the blockchain, but a hash of the data goes to the blockchain. The SSI ecosystem is usually pretty complex, where we have to handle the web standards, the authentication standards, the blockchain, and the decentralized identity network. In SSI network, we have to handle many different layers. At the center, we have a public ledger or a blockchain. Then there is a private identity storage for each user or organization. We have an agent or hub for message transfers as well as to replicate the data. And we have to handle a client device for each user. Ecosystem of a self-sovereign identity network is not limited to only data sharing. How do you get access to such a system? How do you save different type of personal data? Well, for an individual, it's the mobile device or IPFS or cloud storage. However, if you have to store the biometrics data, it has to be saved only in the mobile device, whereas the other data can go to the IPFS or can be stored in an encrypted manner either in the device and on the cloud storage. So here you can see that Alice has got all her personal data saved in her own mobile device. So this personal data can be in a verified credential, which are alphanumeric in nature, like the name or date of birth, blah blah blah, as well as the biometric templates, whereas Bob has his data stored in his mobile device as well as a copy on the IPFS or the cloud storage, so that if the mobile is broken or stolen or lost, then he can retrieve all this information again from the storage. For an organization, the data can be stored on the cloud storage. And again, we have a public DLT, which is responsible for the creation of the decentralized identities and in the reference hash of the claims. And also here, we are able to do any kind of revocation if needed. Now it's time to explore a travel-based use case. In this use case, the user has a smartphone running EarthID's app on it. The user already has passport, visa, and biometric details verified and saved as verified credential in digital form. Now the user visits the airline's website for booking ticket, producing passport, visa in verified credential form. The airline asks for COVID test result, and if the user doesn't have it, then the airline redirects the user to couple of labs from where the user can get tested for COVID. Now the user visits the lab and get himself or herself tested for the COVID. The lab shares a verified credential with the user that the user can save in the mobile phone. The lab also writes a hash of the VC to the blockchain, signing it with own private key. Now the user visits the airline website again for booking the ticket, and now the user can produce passport, visa details, and the COVID test results, and also can share live biometrics. The airline checks all these details and matches with user's face that is there in the passport. And if the payment is through, then the airline can send a verified credential to the user's mobile phone, which is the ticket, the digital ticket. The airline also writes a hash to the public blockchain, signing it with its own private key. Now comes the day of travel. So as soon as the user enters the airport, the user shares all this verified credential with the airport server. Now the airport server checks the hash of the verified credential on the blockchain, and if it matches, then through cameras the airport server can also match the face biometric template of the user with the one that is on the verified credential, and also matches the hash that is stored on the blockchain. And if all valid, then the check gates can automatically sense it from a distance, and they can open it for the travel of the user till the check gates. So the user doesn't have to showcase any of the physical documents in any of these touch points. So the advantages of this model are many, and here the governments can verify the authenticity of the test and can also identify the people who are tested. The airlines has the ability to provide accurate information to the passengers and on the test requirements. And the laboratories have a means to issue digital certificate to the passenger that is recognized by the governments, and the travelers have got all the accurate information on test requirements. They're able to know that who are the labs who can get them tested and from where they need to be vaccinated. So all this information can be shared uh, in a safe way and with utmost privacy and security. Now let's explore some of Earth ID's area of research. The success of a SSI product depends on many different factors. So the first is what kind of crypto or what kind of public key infrastructure we are using so that we can have a safe and secure data transfer. Secondly, what is the scalability and throughput of this model? Can it cater to the needs of millions, if not billion, in the future? Because we all know that this decentralized identity is for general public and their devices. So we need high scalability here. Third is the cybersecurity part handled efficiently, and then is the solution interoperable? Can it be integrated with other decentralized identity network effortlessly? Then what kind of selective disclosure or zero knowledge proof model has been implemented here? Is it robust enough to compare different type of integer values in different modes? For example, greater than, smaller than, not equal to, etc. um, Very important factor here, that who are the validator nodes. So here please note that the public blockchain that we would be using in a SSI network needs to be very different from that in Bitcoin or Ethereum. The consensus model here should not be proof of work as Bitcoin has, or Ethereum one had, which is slow and expensive. What we need over here is either proof of stake or proof of authority, um, or something similar, so that the transactions are super fast and highly scalable, and they can cater to the need of millions and billion people in and their devices. Hence, the validator nodes, or the nodes responsible to handle the consensus process and approve the transactions, have to be run by organizations who are well known in the industry. And finally, how efficiently this SSI network is integrated with biometrics, that also is very important for the success of this network. Mostly because we won't give access to the SSI network on the basis of the same old school user ID, password, or OTP models. Biometrics is the best solution over here for the authentication purpose. So this also plays a very important role. So now let's explore one by one all these features from the Earth ID's point of view. Earth ID uses SHA-256 based hashing and novel ED25519 public key signature system, which is the fastest and safest at the moment. RFID is backed by the Hashgraph DLT, which is well known for its scalability and throughput. And Hashgraph is already tested with 10,000 transactions per second and up to 6.5 million transactions per day with finality within 5 seconds. RFID uses Hashgraph DLT, which is resistant against DDoS, Sybil, and spoofing attacks. RFID is working on integration with other DID networks and with other layers as per the requirements of business. RFID SSI network can share data in traditional zero knowledge proof or self-attested modes. RFID uses finest homomorphic cryptology algorithms for comparing integers in zero knowledge proof mode. For example, we can compare integers as greater than equal to, less than equal to, greater than or less than or not equal to modes to find out a boolean as a output. RFID uses hashgraph that has a council of 19 multinational corporations from around the world to govern the platform and the software that will run on millions of nodes globally. To reach the consensus, instead of mining or proof of work, nodes on Hashgraph gossip with each other, comparing nodes on the transaction history of the network. So Hashgraph's validator nodes are industry leaders in different verticals as Google, IBM, Wipro, Deutsche Telekom, FIS, Tata Telecom, etc., who are the organizations that the industries can trust. Hashgraph is currently integrating with biometric solutions from the leaders in the industry, and we are working on modalities like finger, face, and iris. And in future, we also have plans of integrating with behavioral biometric solutions like gait, voice, signature, etc. And we are extensively working on the decentralized biometric experts. So at Earth ID, we are on the process of building a state-of-art architecture for self-sovereign identity, and we are investing on all the different features, and so that we'll come up with the industry-leading solution in SSI. So here is Earth ID's state-of-art architecture that uses Hashgraph as its public DLT. So users have the option of storing their verified credentials such as name, date of birth, educational certificates, employment certificates, salary, vaccination details, etc. in their mobile device with the help of RFID app running on their device or even on a personal laptop. User can also save their data on IPFS and get a printed copy of their data in the form of a cryptograph or QR code. This is especially useful for people who do not have a smartphone or elderlies or those who cannot efficiently operate the app on their device. So with Earth ID, we can create decentralized identity not only for humans but also for their mobile devices and IoT based machines that can communicate and share information with utmost safety and security. So thank you so much for watching this video. If you want to know more, then you can contact Earth ID. You can directly write to me on LinkedIn, and you can read my book Blockchain for Self-Sovereign Digital Identity, which is publicly available on Amazon. Thank you so much.